Okay, in this video, we're going to be analyzing the position versus time graph and the velocity versus time graph of the Nerf dart that we shot at the go motion. So remember, the go motion uses sound waves, right? So looking here, this is just tracking the barrel of the Nerf gun, right? Here, at this moment right here, and I can actually click on this, and it tells me the distance and the time there, right? That tells me the moment that I started started tracking the bullet, all these points here. Okay, so that's what we're going to analyze, just this box right here. The rest of the stuff we're not worried about. So what we're going to do, you're going to click on View Options in the top right corner here, right? You're going to click on the data table. Turn that data table on. Okay. So then it's taking forever to load because I am recording. And you can make this actually bigger if you want. We're not going to by dragging this here. So, but what's kind of nice is I can click on this and we're just going to look at it for a second. So if I look at this, I know the velocity is negative because the slope is negative, all right? So if I look at this data table, if I look here, I'm looking at all these numbers. This is position, this is time, and this is velocity, and then this one over here is acceleration, all right? So then now, for looking at this, I know the number should be negative for velocity when it's going towards the go motion because you're losing distance. We're going further away from the go motion to actually hitting the go motion right here, all right? So if I look at the position, and I want to look at the position and the velocity, notice where it starts to change to get smaller. I'm going to look at where the position's getting smaller. So it goes from here to here to here. Right? After that, it's roughly getting, it's not really moving a whole lot, but all these are negative. So these are the ones I want to kind of start with, right? This is going to be my initial. So if I click on this, the beautiful thing about that, it takes me to that point. So my initial time in this, my TI, is going to be 1.95 in my example, okay? My TF, my final time, is going to be where the distance is 0. That's the moment it hit the go motion. So if I look down at the data table here on the right where I'm highlighting, so it goes right here. So this line, that should make sense. That is where I hit the go motion at 2.2 seconds. All right, so you would write those things down in your data table, right? And then you want to look at those points from 1.95 is my initial time to 2.2, that's only the time frames I'm looking at, just these points in the data table, 1.95 all the way to here. So where's the Nerf dart going the fastest? Right here at negative 9.9 meters per second. All right. Where's the acceleration the greatest? The acceleration is the greatest here, negative 51.62 meters per second squared. Okay. And so basically, that's what we're looking at. So we're going to use the formula for velocity, velocity equals df minus di divided by tf minus ti. So in this example here, the final time would be 2.20, and in all of these, in yours too, the final distance should be 0 because that is the point where the Nerf dart hit the go motion. My initial time would be wherever I started from, which is what I decided here, where it was from moving to not moving. I chose 1.95. That can be a little bit different, but just make sure you notice that you're picking where it's getting negative and getting faster and faster till it hits the go motion. That makes logical sense, right? So you're going to use that equation to solve for the average velocity of this line over the entire time. But note, the highest velocity on mine is negative 9.46, but that will not be my average velocity in the total time of the Nerf dart, okay? So then also I want you to figure out the average acceleration, and then you're going to use the same data points as well. If you have questions, please ask.